All right, today's day 34 of coding every day until I get employed. Today I decided to go back and finish up this leak code problem. So let's get into it. So I created a stack, or at least I got the solution from Code, and they decided to create a stack, but it was very similar to my own solution, right? So create a stack, right? And then you say, okay, for each asteroid, you're gonna have this collision which says while you collide, right? And the collision logic is based off the fact that if you have an element to the left and it's going right, and you have an element to the right and it's going left, they're going to collide, right? Because this one's positive, this one's negative, you know which direction it's going into. And that's a lot simpler than the logic I had beforehand where I had like, it was ugly, right? But this is a lot simpler, and like there really is only one case in which they collide, which I wasn't thinking about. I was really only thinking of, hey, if I have numbers with differing signs, and in the back of my head I was thinking, well, they could have differing signs, but they could still like be moving in a direction. Like for example, if this one was moving, if this one was moving left and this one was moving right, right, that wouldn't really make them collide. This one would have to move right, and this one would have to move left, right? So that took care of that. And then basically what we did is we said, okay, collision is equal to the top of the stack plus A. And what we do here is that we basically know that whatever value we get from here, we can use to determine which one was bigger. In my code, I decided to get the absolute magnitude. And then from there, use that to see which one's bigger. But I guess this is a lot simpler. And basically you say, okay, if collision is less than 0, that means that the number that was bigger was the negative number, right? Which was the negative number inside the list that you're comparing to the stack. So from there, you'd want to pop that element, and then basically you say, okay, well, if the element inside the stack was bigger, well then we set A equals 0. Now this is very important because I think this is one of those key pieces of information that if I understood it, or more so if I understood how to use it, would have made my solution a lot easier. Let me see where it says it here. Me to asteroids in direction. I think it says it right here. Yeah. Asteroids at I will not equal 0. And basically the Code solution use that to basically say that we can denote whether an asteroid that we're comparing from the list, not the stack, is destroyed by placing it as 0. For me, I was thinking, oh, I could just skip that element, but they placed it as 0 instead, right? And then and this is important later, and then you say the same thing if the collision equals 0, meaning that both of the elements have the same magnitude and they destroyed each other. Well, you want to pop like before, and you also want to destroy the asteroid inside the list, right? So you also set it to 0, and this is where it comes in handy, where you say if A, meaning that if A is not 0, then you append it. So basically you're saying, okay, well, you go back to the list, you check, hey, did we destroy that element? And if you did destroy that element, then you're not going to place it in. But if you didn't destroy that element, then you place it into the stack. And then after that, you return stack. And this code was like almost like, I'm not going to say identical, but this was basically my thought process, but actually done right. Because I was thinking about doing all of this, except I overcomplicated it with the logic here. And then I had this idea of denoting whether or not we destroyed the asteroid inside the list. But I was thinking of using like an extra, I guess I was thinking of using an extra variable with 0 and 1. But I just think like with the way my logic was, it became so hard to track whether or not I was doing it right. So yeah, this solution made a lot of sense, and yeah, that's basically it.